Okay, so in pre-algebra, what we're going to be covering right now is lesson 2.1. And right before we really dive into lesson 2.1, let me emphasize that this is a whole new chapter. If you have not completed the chapter 1 test, okay, or anything related to chapter 1, I recommend you stop this video and make sure that you work on anything related to chapter 1. Once you're done with all that, then you can come back to this video, which is about lesson 2.1. If you've already accomplished all that, then let's get going. Let's talk about lesson 2.1, which are the properties of addition. That's the title of it. So if you want to take out a separate sheet of paper, title it as lesson 2.1, properties of addition. And if we have enough time in the same video, I'll even try to include lesson 2.2. If not, I'll do it in a completely separate video. But this one's about properties of addition. It's on page 45. Make sure you have your textbook out. If you don't have your supplies out, pause the video, get it out now, because I'm about to dive into this lesson right now. Well, properties is just a fancy way of saying the rules of addition. Okay, so this properties that they're referring to, or these rules that they're referring to, are actually in your printed notes. They look something like this, and we're going to be focusing on the ones that say of addition first. Okay, so this one, the additive identity and the additive inverse. Okay, and then the closure of addition. So anything relating to addition, we're going to take a look at all the math rules that we should know. Okay, now the first one is called commutative property. Okay, and commutative property of addition looks like this, where we have a plus b is the same thing as b plus a. So in short, here's a quick way to summarize the commutative property. Okay, basically when you're adding numbers, it doesn't matter the order of the numbers. Okay, so for example, commutative property, we want to make sure that the order does not matter. Okay, so if I had a problem with 4 plus 2, well, 4 plus 2 is the same exact thing. It will equal the same exact thing as 2 plus 4. Okay, and if you actually take a look at example 1 on page 46, you'll see what I'm talking about. They want you to represent parts A and B as commutative property. Okay, so part A says -9 plus 4, and question B says x plus 9. And they want you to show that the order really doesn't matter. So what do they mean by that? Well, if I actually switch this order around, so instead of -9 plus 4 and put 4 plus -9, that equals the same exact thing. Okay, doesn't matter how you write it. That's one of the math rules that everybody should know, is that when you add, whether you do it one way or another, you'll still get the same answer. So in the case of x plus 9, another way of saying x plus 9 equals 9 plus x. Okay, so that's the first rule. The second rule that we're going to talk about is associative. Okay, and again, we're sticking to the part that says of addition. And the associative property of addition is just basically, if you take a look, a plus b plus c equals the same thing as a plus b plus c. But what do we notice about this first parentheses? Well, in this first parentheses, we have b and c inside, and in the second parentheses, we have a and b. So now, one of the key things to know about associative property, which you should write out, okay? So for associative property, the grouping changes. That's the main thing that happens here. The grouping changes. So what does that mean when it says the grouping changes? Well, an example of this would be something like if I had 5 plus 6 plus 8, and 6 and 8 are in parentheses, I can change what's inside the group or inside the parentheses. If it's changed, then you know it's associative. For example, if I change this to 5 plus 6 inside the parentheses and leave the plus 8 alone, you're still going to get the same answer. So it's kind of similar to commutative property where what goes inside really doesn't matter. The grouping changes, but your answer doesn't change. Here's what I mean. If I was to solve each one of these out, we would obviously do what's inside the parentheses first. We would do 6 plus 8, which is 14, and 5 plus 14 is 19. If I was to do it this way, 5 plus 6 is 11, and 11 plus 8 is still 19. So you see what happens inside the parentheses, even though the values change, the grouping changes, right? My answer is still the same. So an example of this would be something like example 2 on page 46 still, okay? And I'm just going to show you one of them. Like A says negative 8 plus 17 plus 43. What would be a way to show this as commutative property? What do you notice is inside the parentheses now? Well, negative 8 and 17. So if I was to write these same numbers, negative 8 plus 17 plus 43, and I wanted to make sure I was showing associative property, I don't want the parentheses to be the same. Just like how they changed here, I'm going to change it. So maybe instead of 8 and 17 inside the parentheses, I'm going to put 17 and 43 inside the parentheses. That's how you show that something is the associative property, okay? Now, can there ever be a time where you have both associative and commutative, right? Actually, you can. If you notice that the order of the number changes, for example, if you have something like negative 8 plus 17 plus 43 equals negative 8 plus 43 plus 17, then yeah, this is actually a mixture of both. The numbers inside the parentheses have changed, but also the order switched. The 17 was first. Now the 17's in the back, okay? So this one is a great example of having an associative property and commutative property. So a few more properties of addition that I need to show you will be on the very next part, okay? Okay, so I'm gonna move this piece of paper and we're gonna actually talk about the additive identity. So identity is kind of the key word here, and that's the word I'm gonna follow, but basically it means I need to keep my identity or keep the same letter. For example, A plus what gets me the same A value? Well, 0. And 0 plus A gets me the same value? Still 0 plus A. So identitive property of addition, so additive identity looks like this. It's basically I have a number plus what will always keep it at that same number. Well, that number here is 0. That's right. Anything plus 0 will get me 6. If I had 12 plus 0, that still keeps its identity. If I had negative 100 plus 0, it still stays as negative 100. If I had banana plus 0, it's still banana, okay? But that's how you handle the identity property, okay? Now, there's another one that's the additive inverse. Now, the additive inverse relates very well with this. However, we talked about that inverse was just a fancy way of saying opposite. Let's see what I'm talking about. So if I asked you what was the opposite of 5, you would most probably say negative 5. Now, I bet you didn't know that when I added 5 and negative 5, that equals 0. That's right. So if I had something like negative 2, what's the opposite of negative 2? That's right, positive 2. And if I add those up, guess what it would equal? 0. Whenever you add your opposite, adding opposites or inverse will always equal 0. Okay? So a good way of looking at this is, another one you can look at is negative 5 plus 5 That equals 0, very similar to that. You can have negative 11 plus 11, okay? You can have 12 plus negative 12, okay? And if you notice, I'm always getting an answer of 0. As long as I'm adding my opposite, it will always equal 0, okay? So now that we have that down, let's kind of look at skill check 3. So skill check number 3. And we are really going to just look at questions 1, 2, 3, and 4. Now, I'm not going to write these out per se, so please make sure if you have your textbook, make sure you're on skill check 3, which is on page 47. And what we're going to do and what it asks us to do is to identify the property that it gives us. So for number 1, okay, it kind of looks like this. They have 13 plus 4 plus 7 equals 13 plus 4 plus 7. We're going to pay attention to some key things. First off, let's pay attention to the order of this. It says 13, 4, and 7, and the next part says 13, 4, 7. So right now, the order of the problem really didn't change, right? Now, when the order does change, and let's just say does not matter. Sorry about that. When the order does change, then it's commutative property. However, because we're keeping the same order, it's not commutative. However, take a look at what's inside the parentheses. Do the numbers change inside the parentheses? Yes. That means the grouping changes. That means this is the associative property. So the answer to number 1 is associative property. Now number 2 says 8 plus 6 equals 6 plus 8. This time you can tell that the order of the number switches, and we just talked about that. That is commutative property. Okay. The third one, number 3, says 4 plus 0 equals 4, meaning it's going to keep its what? Identity. That's right. This is what we call the identity property. And the last one we have here is negative 24 plus 24 equals 0. I have two numbers that are opposites of each other, and another way of saying opposites is, guess what? Inverse. So this is the inverse property. This is a good way of knowing how to do each and every one of these. Now that the last one I'm going to talk about, okay, is the closure property. And I'm even going to do one of the ones straight out of the homework. So first off, let's talk about the closure property. I'll give you an example of it, and then we'll even do one from the homework. The closure of addition is when you add two numbers in a set, the sum is also in the set. What do they mean by set? I guess we'll find out now, okay? So let's talk about question number 9, straight from your homework. This is from your homework on page 47. So consider this a free answer, you guys. So number 9 says, since negative 3 and 5 are integers, okay, negative 3 plus 5 is an integer. And it's kind of like we're saying true or false, really, is what we're going to be doing here. We're going to be saying, yes, it's a closure. No, it's not a closure. When we say, yes, it's a closure, that means we're saying it's true. And when we're saying that it's not a closure, that means it's false. That's for you to know, okay? So let's kind of go over what a closure is a little bit more in detail, okay? So I'm going to kind of fold this up for a moment. But as you can see here, we have -3 and 5. They tell you that these are integers. You do really need to know what an integer is, but an integer is just a whole number and their opposites. In other words, it can be a positive whole number or a negative whole number. And both of these so far are positive and negative whole numbers. So in other words, when I add them, is my answer still an integer? Let's see. Well, let's actually do -3 plus 5. There are different signs, so we know we're going to subtract. 5 minus 3 is 2. And since 5 is positive, it's a positive 2. Now let me ask you, is this an integer? Is positive 2 an integer? Yes, it is. And because it is, our final answer here is closure. That's literally all you need to write, meaning you're saying that yes, this is true, this is an integer, meaning yes, this is a closure. Okay? This gives you kind of an idea of how to look at all the different properties, okay? Now, since we did additive in all the addition and additive properties, I'm going to go very quickly through the multiplication one, which is actually lesson 2.2. So lesson 2.1 was about properties of addition. Lesson 2.2 is about the properties of multiplication. Now there's really only one new property that you're going to read about here that we didn't really get to talk about for 2.1. But 2.2 starts off on page 51, okay? So let's start it off. First off, it's basically, some of the properties are pretty much the same. For example, there's a commutative property of addition, but now there's a commutative property of multiplication, okay? Meaning, it's very similar, the order just switches around, but instead of an addition sign, a multiplication sign. So the example of a commutative property of multiplication would look something like this. 6 times 2 equals the same thing as 2 times 6. Again, the order changes, but it doesn't really matter because 6 times 2 is still 12 and 2 times 6 is 12. Okay? So that just tells you how commutative property works. Associative property, there is an associative property of multiplication. But now instead of addition signs around it, there's multiplication signs. So for example, if I had 1 times 2 times 3, and the 2 and 3 had parentheses, if we wanted to change the grouping of it, right, instead of putting the parentheses around 2 and 3, maybe I could put the parentheses around 1 and 2. And that is our associative property. Remember, we still get the same results no matter how they're grouped, but the grouping or the numbers inside the parentheses change. The next one I'm going to kind of reflect back on, but it's a little bit different than its addition, is now the multiplicative identity. Now, the one that we did earlier with the addition one, it was basically the identity for addition was anything plus 0 kept its identity. Now, this time we're dealing with multiplication. So what keeps its identity? In other words, a times what keeps a? That's right, a times 1. So to keep its identity, instead of adding 0, we're going to be multiplying by 1. For example, if I told you to keep the identity of 4, in other words, you want the final answer to equal 4, 4 times 1 is going to keep it as 4. How about if I told you I wanted you to keep it as -7? Well, -7 times 1 is -7, okay? That's all the rule for multiplicative identity. Instead of adding 0, we're multiplying by 1. Then you have the multiplicative inverse, and this one is the tricky one, so please be prepared. The inverse now is a bit different. So the inverse, when we were talking about addition or the inverse, the way the inverse works, and let's see if I'll pull out the right paper, was basically getting the opposite sign. So if one was positive, my inverse was negative. If one was negative, my inverse was positive. Now with multiplicative, it doesn't work that way, okay? Now the inverse for multiplication, and if you have to pause this part, I don't blame you. It gets a little tricky, but I promise you it gets pretty easy. All you're doing is actually this. Watch it. You know that, let's say they give you the number 3, and you know that you're dealing with multiplication because it says multiplicative. Now the inverse of 3 is actually 1 over 3, and this will always equal 1. Now I'm going to do a few more examples, and I promise you I think you're going to get the groove. For example, if I had 6, the inverse of 6 is 1 over 6, and the inverse when I multiply them will equal 1. If I had r, my inverse of r is 1 over r, and that equals 1. So if you notice, it's always the same number, but now with just a 1 on top, multiplying it with a 1 on top. So Mrs. Elliott, what if they already give me something like 1 over 5? What would be the inverse of 1 over 5? Well, you're just going to multiply it by a regular 5, and that is the inverse, and that will get you an answer of 1. So that's pretty much a few of the properties you've already seen, and I'm going to show you one more right now, which is the distributive property. Okay, and this is on your printed notes, and I'm going to show it to you on your printed notes first. So the distributive property kind of looks pretty plain and simple, but I will do 2 examples so you kind of get a groove of what it looks like. But basically, distributive property means anytime I have a number outside parentheses and it's directly next to it, you're going to be multiplying the numbers inside. So a times b, which is ab, and a times c, which is ac. Seems a bit weird now, but let me show you what I mean. Let's say if I have the numbers 4, and in parentheses right next to it, I have 1 plus 3. Okay? Now there's nothing here, and because there's nothing next to this 4, you can automatically assume that there's a little times there. And what we're going to do is we're going to multiply 4 times 1, and let's actually write that out in parentheses. 4 times 1, and because I have a plus sign, I'm going to put a plus sign there, and do the next multiplication, 4 times 3. So it's kind of like I'm doing 4 times each number that's inside. So 4 times 3. And that's how you do distributive property. Let me do another one so you kind of get a groove. Let's say if I have 2, 9, and 7, again, I want to multiply the outside with the first inside, which is what? 2 times 9. I'm going to follow the plus sign and put it in between, and do the next one, 2 times 7. And this is why distributive property is more under multiplicative, because you really are multiplying each outside with each of the insides of inside of the parentheses. And this is lesson 2.1 and 2.2.